When you look in the mirror this morning, your left hand appears on the right. You've seen this your entire life. You've never once questioned it. But here's what nobody tells you. The mirror isn't flipping left and right. It never was. And the moment you understand what it's actually doing, your bathroom will never look quite the same. Let's start with the obvious question. Why does a mirror flip left and right, but not up and down? Think about it. Both are directions. If the mirror is reversing one axis, why not the other? Your head is still on top, your feet are still on the bottom, but your left hand is suddenly on the right. What is the mirror choosing to reverse? And why? Here's the trap. Most people answer this question wrong, including scientists who should know better. They say, the mirror flips left and right because that's just what mirrors do. That's not an answer. That's restating the question. So let's actually figure it out. Stand in front of a mirror and point at it with your right hand. The figure in the mirror points back with the hand on your left side. That looks like a left-right reversal. Now lie down on the floor and look at the same mirror. Suddenly what was left-right is now top-bottom. Your feet are on the right of the mirror. Your head is on the left. The mirror hasn't changed. You changed your orientation, and the whole reversal shifted with you. That should tell you something. Here's what a mirror actually does. One thing only. It reverses front and back, the axis pointing from your nose toward the mirror and back out again. That is the complete optical operation of a flat mirror. It takes the dimension running perpendicular to its surface and flips it. Nothing else. It does not touch left and right. It does not touch up and down, just front and back. So why does your left hand appear on the right? Because of what your brain does with that front-back reversal. When you look in a mirror, your brain automatically imagines, what would this look like if that person turned around to face me? When two people face each other, one of them physically rotated to do so. Left and right swap. Your right hand is on my left. My right hand is on your left. That's rotation, not reflection. The mirror didn't rotate you. Your brain imagined you rotating. And your brain is where the left-right flip happens. Say that again. The mirror does not flip left and right. Your brain flips left and right by imagining a rotation that the mirror never performed. Now here's where it gets genuinely strange. Try this thought experiment. Write the word left on a piece of paper and hold it up to a mirror. The reflection looks reversed. It reads like a mirror image, left and right, flipped. Now rotate that paper around the vertical axis. Physically turn it to face the other way, and look at it directly. The writing is also reversed. Exactly the same result as the mirror. Because what a mirror does is equivalent to flipping an object through its front face, which is exactly what you do when you rotate something around a vertical axis to show its back. Rotation swaps left and right. Mirrors simulate the visual result of rotation. Your brain reads it as a left-right reversal. But the mirror just reversed front and back. This is the difference between a right hand and a left hand. Your right hand, rotated in every possible direction in three-dimensional space, never becomes a left hand. Never. Try it. You can flip it upside down, spin it sideways, hold it behind your back. It's still a right hand. A mirror produces a left hand from a right hand. No rotation can do that. That's a fundamentally different kind of transformation. Mathematicians call this chirality, handedness, the property of an object that cannot be superimposed on its mirror image by any rotation. And this is the moment a puzzle about bathroom mirrors connects to something much deeper. Think about the molecules your body is made of. Amino acids, the building blocks of every protein in every living thing on Earth, come in two mirror image forms. L-amino acids and D-amino acids. Same atoms, same number of each, same chemical bonds. The only difference is their handedness. They are mirror images of each other, related by exactly the reflection a flat mirror performs. And here's the strange part. Almost all life on Earth uses only the left-handed form, L-amino acids. Not a mixture, not random, left-handed, almost exclusively, everywhere. In every organism that has ever lived. Why? Nobody fully knows. It's one of the unresolved questions in the origin of life. But what you need to see is this. The chirality of your amino acids, the handedness of the molecules that make your proteins, your enzymes, your DNA, is the same property you observe when you notice your left hand appearing on the right in a bathroom mirror. It's the same geometric fact, one seen at the molecular level, one seen at the human level. Pull on that thread. In 1956, two physicists named Tsung-Dao Lee and Chen-Ning Yang asked an uncomfortable question. Is the universe symmetric under mirror reflection? Everyone assumed yes. The laws of physics should work the same way in a mirror image universe. Why wouldn't they? But Lee and Yang looked closely at the weak nuclear force, the force responsible for radioactive decay, and they weren't sure. They proposed an experiment. Zhensheng Wu ran it. She cooled cobalt atoms to near absolute zero, aligned them with a magnetic field, and watched which direction the electrons flew out when the cobalt decayed. If the universe were mirror symmetric, electrons should fly out equally in both directions. They didn't. The weak force preferred one direction. The mirror image version of the decay was not equally likely. In fact, certain processes that happen in the real universe simply cannot happen in a mirror image universe. They are physically forbidden. The universe itself is not symmetric under mirror reflection. Li and Yang got the Nobel Prize in 1957, 1 year after the prediction. That's how clean the result was. And now here's the thought that tends to land. Imagine you're in contact with an alien civilization on the other side of the galaxy. You can exchange radio messages, but you've never met. You want to explain to them which hand is left. You can describe every physical law, every chemical structure, every mathematical relationship. But can you tell them which hand you mean without showing them? It turns out you can, but only because the weak nuclear force violates mirror symmetry. You could say, run the Wu experiment with cobalt-60. The electrons will be preferentially emitted in one direction. Call that direction up. Now define left as the direction to your left when you're facing the direction electrons prefer to travel. Your alien, anywhere in the universe, runs the same experiment and identifies the same physical direction. You've communicated left without ever meeting. If the universe were mirror symmetric, this would be impossible. There would be no experiment they could run to pin down what you mean by left. Left and right would be purely conventional, human labels with no physical anchor. The fact that left is physically real, that the universe genuinely distinguishes the two, is because of parity violation. The same asymmetry that puzzles people in front of bathroom mirrors is the same asymmetry that the weak force exploits at the level of atomic nuclei. What started as a question about your reflection connects, without a single break in the chain, to a Nobel Prize in particle physics, the biochemistry of every living thing, and the structure of the laws of nature. Let me show you how deep this goes. Two mirrors facing each other at an angle. You see your reflection in both. Keep going, and you see a reflection of a reflection. Now something strange happens. The double reflection looks different from a single reflection. Your hair parts on the other side. Your face looks subtly wrong to you, because this is the first time you've seen your face the way other people see it. Not mirror reversed, but actually as you appear to the world. Most people find it slightly unsettling. Their face looks asymmetrical in a way the mirror never showed. Why does a double reflection produce that? Because two mirror reflections compose to give a rotation. One reflection is fundamentally different from any rotation. It produces chirality. It changes handedness. But two reflections cancel each other out. Two flips combine into a turn. The mathematics connects back to the same symmetry group that physicists use to describe the structure of space itself. This isn't coincidence. It's the same underlying geometry. Now think about the letter R. Hold it up to a mirror. It looks reversed, like its mirror image. Now hold up the letter O. Same mirror, same reflection. It looks identical. Why? Because O has mirror symmetry. Its left and right halves are reflections of each other. The mirror reversal of O is O. But the mirror reversal of R is something that doesn't exist in our alphabet, a backwards R. Some letters have chirality, some don't, just like hands, just like amino acids. And this pattern, The divide between things that are symmetric under reflection and things that aren't runs through all of chemistry. Molecules that are mirror images of each other, like the L and D amino acids, are called enantiomers. They have the same molecular formula, the same bonds, the same melting point, the same boiling point. Almost every physical property is identical, but they interact differently with other chiral molecules. And biology is full of chiral molecules. So enantiomers can behave completely differently in a living system. Here's a stark example. Limonene is a molecule found in citrus fruits. The two enantiomers, the L and D forms, are mirror images of each other. One smells like oranges, the other smells like lemons. Same molecule, different hand, different smell. Because your smell receptors are themselves chiral, they're made of L amino acids, and they distinguish the two mirror image forms. This is not a minor detail. The chirality of molecules has real consequences for drugs, for flavors, for biological activity. One enantiomer of a drug can be medically active. The other can be inactive, or toxic. Thalidomide, prescribed in the 1950s, was a mixture of two enantiomers. One treated morning sickness. The other caused severe birth defects. Same molecular formula, different handedness, completely different biological effect. The geometry you observe in your bathroom mirror, the transformation that cannot be achieved by rotation, has direct consequences for medicine. Here's one more piece that almost never gets mentioned. Left and right are not objective properties of the universe in the way that mass or electric charge are. Left and right are relational. They're defined relative to an orientation, relative to forward and up. If you flip upside down, what was your left becomes your right. There's no absolute leftness floating in space, the way there's absolute mass. Left and right exist only relative to an observer. This is exactly why the mirror puzzle is so puzzling. The mirror preserves objective physical properties, but it changes a relational property, handedness. And relational properties feel objective to us because we're always oriented the same way. We always have a front, a back, a top, a bottom. The mirror image of a person looks wrong because their relational properties, the side their watch is on, which hand they write with, are reversed. But parity violation changes this. The Wu experiment gives the universe a preferred handedness that is objective and physical, not just relational and observer dependent. The universe doesn't just label directions differently for different observers. It actually does different physics in different handedness. That's the strange move. The universe takes what seems like a merely conventional distinction and makes it real. Emmy Noether, one of the greatest mathematicians of the 20th century, proved in 1915 that every continuous symmetry of physical law corresponds to a conserved quantity. Rotational symmetry corresponds to conservation of angular momentum. Translational symmetry to conservation of momentum. Time symmetry to conservation of energy. Mirror symmetry, if it held perfectly, would correspond to conservation of parity. But parity is not conserved. The weak force breaks it, which means one of the deepest symmetries we assume the universe had, the equivalence of left and right, turns out to be false. The universe chose a hand, and we can see the evidence of that choice everywhere. In the amino acids of every living thing, in the decay products of radioactive cobalt, in the mirror on your wall, which has been quietly hinting at something strange your entire life. And here's where it gets personal in a way most people don't expect. Your face. Look at it in a mirror. Now find a photo of yourself. Not a selfie taken with the front camera. Those are mirror flipped. Find a photo taken by someone else. A normal photograph. Most people find their photo face slightly off. Something feels wrong. Their friends and family say, "That's exactly what you look like." But to the person in the photo, it looks strange. The reason? You've spent your whole life seeing yourself in mirrors. You know your face mirror reversed. The mirror version is your normal. But photos show you as you actually appear to the world. And you're not used to that version. This is a genuinely strange consequence. You know your own face less accurately than the people who know you. Your self-image is literally a geometric transform away from reality. Not because you're deceiving yourself, but because the only instrument you routinely use to observe your own face reverses the front-back axis, and your brain consistently interprets that as a rotation it never performed. Now consider what happens when you meet a famous person for the first time. Their face looks slightly wrong, familiar but off. Because you've seen them in thousands of photographs, their photo face is your reference. But they're standing in front of you as they actually are, and your brain is pattern matching against the photo version. This happens in the other direction with mirrors. Look at a celebrity's face in a mirror sometime. You'll notice it looks strange, because you know their face from photos, not from mirror reflections. Their reflected face is the version you've never seen. The mirror has been quietly introducing a subtle error into your self-perception your entire life. And the error is the same one at the heart of the puzzle. You see front-back reversal, and your brain interprets rotation. Most people go their entire lives without noticing that the face staring back at them from the mirror is not the face other people see. It's a flipped version, and nobody told them. Let's run through the full chain one more time, because it's worth seeing all at once. You notice your left hand appears on the right in a mirror. You ask why. You find that mirrors reverse front-back, not left-right, and the apparent left-right flip comes from your brain imagining a rotation the mirror never performed. You notice that rotation and reflection are different operations. A reflected right hand is not a rotated right hand. It's a left hand. That property, chirality, handedness, shows up in chemistry at the molecular level. Amino acids, L forms and D forms. Life chose one hand and stuck with it for 3.5 billion years. Nobody fully knows why. The handedness of molecules has real biological consequences. Smell, drug activity, toxicity. You ask whether the universe itself has a preferred handedness. In 1956, two physicists guess it might. One experimenter checks. In 1957, they have the answer. Yes. The weak nuclear force violates mirror symmetry. Certain processes in our universe cannot happen in a mirror image universe. They are physically forbidden. The universe chose a hand, and because of that, you can communicate left to an alien civilization across the galaxy using nothing but physics. That chain has no gaps. Every link is solid. And it all starts with you noticing something so ordinary you never thought to question it. That's what physics looks like when you follow it honestly. Not just the things that are obviously strange, the black holes and quantum entanglement. The ordinary things, looked at closely enough, are just as strange. Sometimes stranger. Your bathroom mirror is one of the most philosophically loaded objects in your home. And it doesn't even flip left and right. You do. If something shifted, if the mirror looks different now, or if you're still turning over the alien thought experiment, leave a comment. Which part landed hardest? The front-back reversal? The amino acids? The weak force preferring one direction? Or just realizing you've been misreading a mirror your entire life? And if you want to keep following chains like this, simple questions that lead somewhere nobody expected, subscribe. That's what this channel is for.